Have you ever looked at a massive video game or a huge social media app and just wondered, how on earth do they build that without it all collapsing into a giant mess of code? Well, the secret isn't just about writing more code. It's about how you organize it. So today, we're going to break down one of the most powerful ideas in all of programming. I mean, this is the big question, right? Once you get past writing a few simple scripts, how do you handle thousands or even millions of lines of code? How do you stop it from turning into this spaghetti monster that nobody can read or fix? The answer isn't some fancy tool. It's a completely different way of thinking about your code. So, let's really get to the heart of the problem here. For little, tiny tasks, a simple step-by-step list of instructions works great. It's like a recipe for making toast. But that same approach, well, it becomes a total nightmare when you're trying to write the recipe for a 5-course gourmet meal. Okay, take a look at this. It's a super basic BMI calculator, written in what's called a procedural style. You've got some data, like your weight and height, and you've got some functions that do stuff with that data. It's all just kind of mixed together. For a tiny program like this, it's fine, it's easy. But, and this is a big but, this style has a hidden and pretty dangerous flaw. Right. Now imagine that same style, but scaled up for, say, an entire operating system. You'd have data and functions scattered all over the place. A tiny change you make over here could unpredictably break something way over on the other side of the program. It becomes this tangled web that is just impossible to maintain. So, to solve this scaling problem, programmers came up with a whole new way of thinking. It was a complete paradigm shift, and they called it object-oriented programming, or just OOP for short. And it is all about bringing some serious structure and order to all that chaos. And here is the absolute core idea. Instead of having your data and your functions just floating around separately, OOP bundles them together into these neat little packages called objects. Think about it like this. Instead of having flour, sugar, and eggs all over your kitchen counter, you've got a single cake mix box that has everything you need, the ingredients and the instructions all in one place. Now, to really get this, we need a good analogy. And honestly, the best way to understand OOP is to think about the relationship between an architect's blueprint and an actual building. So, in the world of OOP, the blueprint is called a class. And this is a super important point. A class is not the thing itself. It's the idea, it's the plan, it's the description of the thing. It lays out all the properties it's going to have and all the actions it will be able to do way before you ever actually build it. So yeah, a class is like the architect's detailed blueprint for a house. The blueprint says the house will have doors, it'll have windows, it'll have a certain number of square feet. And it also describes the things you can do, like how the doors can open and close. And this right here, this is basically what that blueprint looks like to a programmer. It's a simple little visual plan. The top part is the name of the class. The middle part lists all of its data, its properties. And that bottom box lists all of its functions, the actions it can perform. Okay, so if the class is the blueprint, what's the actual building? Well, that's the object. An object is the real physical thing that you've constructed based on the plans from that class. And this is where it gets really powerful. You can take one single house blueprint, one class, and use it to build an entire neighborhood of identical houses. Every single one of those houses is its own separate object, but they all share the same structure and rules from that original class. All right, so let's pop the hood on one of these class blueprints. What's actually inside? Well, it turns out that every single class, no matter how complicated it gets, is built from just two fundamental parts. First up, you have its data. These are basically the attributes that describe what the object is, its current state. And second, you have its functions. These are the behaviors that define what the object can do, what it is, and what it does. That's it. Let's use a car, for example. The data for a car object would be stuff like, what's its current speed on the speedometer? How much gas is left in the tank? What gear is it in? These are all of its properties. And the functions for that very same car object would be the actions it can take, accelerating, hitting the brakes, turning the wheel, shifting gears. Now, do you see it? The data, like the speed, and the functions that change that data, like accelerating, are now bound together in one logical package. That right there is the magic of OOP. But just bundling things together isn't the only trick. OOP also brings in this really critical idea for preventing bugs and making sure your code is solid, protecting your data. It's a concept called encapsulation, and the idea is actually pretty simple. You want to protect an object's important data from the outside world. Think about a car's engine. The engine itself is private. It's hidden under the hood, protected from you just messing with it. But the steering wheel and the pedals, those are public. They're the safe, controlled way you interact with the engine. You don't directly change the engine's RPMs, you press the accelerator pedal. Take a look at this piece of code. See how the student's roll number is marked as private? That means that no other code anywhere outside of the student class can just reach in and change that number whenever it wants. It's now protected. And this is what happens if you try to break that rule. The program just stops. It won't even run. It throws an error at you. And this isn't a bug. It's a feature. This is the code's own security system stopping you from making a mistake that could mess everything up. So the whole point is, you have to play by the rules the class sets up. To safely change that private, protected data, you have to go through the public functions, the front door, that the class provides. We usually call these getters and setters. They act like a little security checkpoint, making sure the data never gets changed in some weird or invalid way. Okay, let's bring this all together. Remember that little BMI calculator from the beginning? Let's go back to it and see what it looks like after getting a complete OOP makeover. On the left, you see the procedural tangle we started with, data and functions all jumbled up. And on the right, the OOP version. I mean, just look at the difference. All the logic for the BMI calculation, the data and the functions that use that data are now perfectly contained inside a single, clean BMI class. It's organized, it's self-contained, and it's so much easier to understand just by looking at it. And that, right there, is the payoff. So what do you get for thinking this way? You get way better organization because all your related code now lives together. You get reusable code because you can stamp out as many objects as you want from that one class blueprint. And you get a huge boost in safety because that whole encapsulation idea protects your data from being corrupted by accident. This whole transformation, going from a messy script to a clean, well-defined object, it isn't just a neat little coding trick. It is the fundamental building block for pretty much all modern software. This is how you go from a few lines of code to a massive application without everything falling apart. So the question is no longer how to build big things, it's what are you going to build?